This lesson is about absolute value. My objective for this lesson is I can solve absolute value equations. Now this will be the first part. We'll solve simpler absolute value equations and then move on later to more difficult absolute value equations. But here we want to tie absolute value to the interpretation of what it looks visually on a number line and then solve some simple equations. So let's start off with what we know. When we look at this information, the absolute value of a positive number is just that number. So absolute value of 4 is equal to 4. So absolute value does absolutely nothing to a positive number. But a negative number, it turns it into the positive. It takes and turns it into its opposite. So the absolute value of negative 4 is also equal to 4. Now how that interprets on this number line is, absolute value of 4 is saying how far is this point away from 0 on the number line. And notice that when we do that, we go a positive 4 units. Now, distance on a number line doesn't represent by positive or negative, so when I go to the negative 4, I also go 4 units. I go in the negative direction, but it's 4 units away from 0. So that's where both the positive and the negative give me the exact same answer. So when I look at this problem here and I ask the absolute value of x is equal to 4, what we're asking is what numbers could you put in there for x and get 4? Well, our answers are both negative 4 and positive 4 because both of those are 4 units away from 0 on the number line. But when I ask the absolute value of what number is equal to negative 4, because absolute value represents distance on the number line, you can't have distance be a negative, so absolute value will never give you that negative value when it's just that x, and so I get no solution for this. It's the empty set. So when I look at these three problems, what the simplest way to think about it is, when you have absolute value of x equal to 8, you're thinking, what is 8 units away from 0 in both directions? So that would be 8 and negative 8. Now if you're doing it algebraically rather than on the graph, the way to think about it is you need two cases. You need when this inside part is equal to 8 itself, and then remember it took its opposite to when you had a negative in there, so I want the opposite of x equal to that 8 as well, 8 units away. And so I get this, when I multiply by negative 1 on both sides, I get x equal to negative 8. So I get two answers, negative 8 and positive 8 for the answer. So that's how I see it graphically, and this is how you do it algebraically with two cases. Now on this one, because it's not just the variable itself in there, but x minus 5, we want to know what would give you 0 on the inside here. Well, notice 5 minus 5 would give you 0. So 5 is what we're actually centering our number line on. And what we want to know is what numbers are 2 units away from 5. That takes us out to 7. And then also 2 units in this direction takes us out to 3 when we go that way. So I get two answers, 3 and 7. Well, let's look at it algebraically. So I set up my first case where the absolute value, the first case is it does absolutely nothing, and so I solve that and I get x equal to 7, but you can't forget the second case. That's not the only answer. The other possibility is where I take the opposite of what's on the inside of my absolute value. So the opposite of this, I'll put it in parentheses. So I get the opposite of x plus 5 equals 2. Subtract 5 from both sides. The opposite of x equals negative 3. And now I multiply by negative 1 on both sides, and I get x equal to 3. So I get my two answers of 3 and 7, which we saw represented as 2 units away from 5 on the number line. So our last example here is because we want to look at this absolute value, and the inside of it, what would give me 0 on the inside there? Well, if I put in negative 6 there, that would give me 0. Negative 6 plus 6 is 0. That would center it there. So I want to go now 10 units away from negative 6 in both directions. 10 units to the positive will go 4 when I go 10 units out this way. And when I go 10 units in this direction, the other direction, that will get me to negative 16. That would be my solution on the number line. Let's do it algebraically with our two cases. First case, you just write it without the absolute value. So the absolute value in one case does absolutely nothing. And so we subtract 6 from both sides and we get x equal to 4. And then the second case is whatever's inside there, we make it into its opposite. So I'm going to take the opposite of parentheses, x plus 6, and I'm going to set that equal to 10. That's 10 units away. Distribute through the negative, so the opposite of x minus 6 equals 10. Add 6 to both sides, the opposite of x equals 16. And then multiply by negative 1 on both sides, and you get x equal to negative 16. So my two solutions are negative 16 and 4. So when I look at these problems, my objective was to solve absolute value equations. To start off with, I've now looked at how it relates to number lines and how we can do simpler problems to get our answers to these equations.